Hello everyone, this is Eswar Banala, working as an Associate Professor for Vidya Jyoti Institute of Technology, Hyderabad, Telangana. The course which we chosen is Computer Graphics and the topic is Two-Dimensional Transformations. Learning objectives of today's lecture are: define two-dimensional transformations, which will come under the lowest level of Bloom's cognitive level, recall. And the second learning objective is explain translations, rotations and scaling transformations in two dimensionals. This learning objective will come under the Bloom's cognitive level, understand. And the agenda points for today's lecture are: introduction to two-dimensional graphics, which covers the transformations of two-dimensional, translations, rotations, scaling. Coming for the 2D transformations. First of all, what is transformations? The geometrical changes of an object from one position to another modified position. And why transformations are needed? To manipulate the object location and to display the modified object without having to redraw it. So after transformations, the object shape or the location will be changed after performing the transformations in graphics. And the two-dimensional transformations can be done in two ways. One is based on object and the another is based on coordinate transformation. The object transformation alters the coordinate descriptions of an object with respect to translations, rotations and scaling, and the coordinate system will be unchanged in the way of object transformations. The coordinate system will be as usual as like in the initial state. And the second way is coordinate transformations, which will produce the different coordinate system. That means the initial coordinate system will be changed or modified to the another coordinate system. And let me discuss the first type of transformations in two-dimensional translations. A translation moves all points in an object along the same straight line path to the new positions. If x and y are the positions, initial positions, and we consider this tx and ty is nothing but the distance which was moving towards x, called as tx, and the direction moved towards y is ty. So after adding the value tx, the distance tx is added to the original point x, and the ty distance is added to the original point y, so that we can get the new coordinate points x prime and y prime. So which the matrix, which the components which we can do here is p prime x is nothing but sum of px and the new distance tx. P prime y is nothing but the py and the distance of ty. And this is what the matrix form which we can perform the translations in two-dimensional translations. Coming for an example, so if this is the point, original point, and this point is the new point, which my point has to be translated from this location to this location with the coordinate axis. Now the new distance which this point we are going to get, So the x point is having the distance called tx, and this is what the ty distance. Example, if I am going to consider this point as a 2.2, x value as 2 and y value as 2, and I move towards x direction 6 points, and I move towards the y direction 4 points, and I got the value will be 2 plus 6 will be x prime, and 2 plus 4 will be y prime values. This is translations, equations, and the matrix form. And the second transformation is rotation. Rotation repositions all the points in an object along a circular path in the plane centered at pivot point. First, we will assume the pivot is origin point, and the point which original point is P, and the displacement is going to be done in the circular path. In the translations, we have distance is going to be done in the straight line path. In the rotation, the path will be circular path. You can observe this. So the original point is P, and it moved towards left with the theta angle, which gives the P prime value. And this we required a little bit trigonometric concept, which we have cos phi equal to x by r, sin phi equal to y by r, so that we can get the x value equal to r dot cos phi and the y value equal to r dot sin phi. This is theta direction, theta angle, which the point moved from P to the P prime point, and phi is an angle from origin to the original point. And this is the radius r of the r. This r and this r will be same, but theta is nothing but the displacement angle, and phi is nothing but original angle of the point P. And to get the values of x prime, we can use this equations, and to get the y prime, we can use this equations. These are what this is x prime r dot cos phi cos theta minus r dot sin phi sin theta. For y prime equal to r dot cos phi sin theta plus r dot sin phi cos theta. These are the identities of trigonometry which we have already learned in intermediate level. These are the equations, final equations, which we can get for P prime x and P prime y. And the matrix form of the rotation is R equal to cos theta minus sin theta, cos theta. Example, find the transformed point P caused by the rotation P equal to phi comma 1 about the origin through an angle of 90 degrees. The 90 degrees is nothing but the theta, and the equation which we performed for the rotation is the rotation matrix is multiplied with the point called x comma y, so that we can get the new point with this values again here. So 5 and 1 are nothing but the points which will be multiplied with the theta of cos 90, sin 90, sin 90 and cos 90 respectively. So finally, after substituting the values of cos and sin, we can get the values of cos 90 as 0, sin 90 as 1, sin 90 as 1, and cos 90 are 0. So the final point is -1 and 5. So these are the values of x prime and y prime. And the last transformation is scaling. Scaling changes the size of an object and involves two scaling factors Sx and Sy for the x and y coordinates respectively. Scales are about the origin. We can consider p prime x is equal to Sx into px, p prime y equal to Sy multiplied by py. And the matrix of scale matrix is Sx and Sy. Sx is nothing but the displacement of x and Sy is nothing but the displacement of y. If you consider this as one point, so if you observe previously the size is small, after performing scaling, the size of the point P is elongated. So the object size was increased after performing the scaling. See, this is the original object and now the object size was increased with, for every point we need to calculate the point of P prime for point A, point B and point C. It's a scaling example. Once again, we are reducing the size of scaling here. Previously the original size is large. Now the size was reduced a little bit. Example again. This is what P as 2, 5 and Sx distance is 0.5 and Sy distance is 0.5. So the P prime values will be getting a little bit distance, moving forward for increasing the size in this way. So finally, the matrix for 3 dimensions we may get for the rotation matrix and the scalar matrix. So additional row and additional column will be introduced for 3 dimensions. This can be continued in the next session. Thank you.